Intricate Devo, intricate.
Hey everyone, welcome back to Intricate Devo, the channel we turn confusing programming concepts into simple, visual, and actual fun lessons. Today we are diving into one of the most important topics in Java, object-oriented programming. Now I know what some of you are thinking, modifiers sounds boring. But trust me, modifiers are the secret security guards, rule makers, and power controllers of your Java program. Without them, your code would be complete. By the end of this video, you will finally understand what access modifier really do, why private is super important, how static works, what final actual means, and even advanced concepts like volatile, synchronized, and transient explained in fun real-world analogies. So grab your coffee, open your IDE, and let's jump right in. But before we start, if you want to master Java, crack coding interviews, and become a stronger developer every single week, hit the subscribe button right now, turn on the notification, smash the like button, because it will genuinely helps the channel grow and keeps this tutorial coming. Alright, let's begin. What are modifiers? Imagine you are building a huge apartment building. Now obviously not every room should be accessible to everyone, right? Some rooms are public, some are private, some are only for family members, and some are staff only. Java has exactly same idea. Modifiers are simply keywords that control who can access something, what behavior it has, and how Java should treat it. And Java split modifiers into two big categories, access modifiers and non-access modifiers. Let's tackle access modifier first. Access modifier control visibility. Basically, who is allowed to touch this code? There are four main access modifiers in Java: public, private, protected, default, and each one gives a different level of access. First one, public, open to everyone. Think of public like a public park. Anyone can enter. If a class or a method is public, every other class can use it. Example, public void start engine. System.out.println engine started. Any class anywhere can call this method. Private, your secret room. Now private is the opposite. Private means only this class can access it. This is the foundational of something super important called encapsulation. Imagine your ATM pin code. Would you want to random people access it directly? Absolutely not. That's why variables are usually private. Example, private string password. Now no outside class can directly touch the password. That's security. That's clean design. That's professional Java development. Protected, family access. Protected is the like family access. Classes in the same package can use it, and child classes can also access it through inheritance. This becomes super useful in large OOP system. Default, package friends only. Now here tricky one. Default access happens when you write no modifier at all. Java automatically says, okay, only classes in the same package can use this. Think of it like co-workers inside the same office building. Best practice. Here golden rule professional developers follow. Make a variable private by default, then expose them safely using getters and setters method. That keeps your data protected and your code clean. Non-access modifiers. Now things get really interesting. Non-access modifiers don't control visibility. Instead, they change behavior. These are like superpowers for your code. Let's look at the most important one. Static, shared by everyone. Imagine an office water cooler. There is only one water cooler, but everyone shares it. That is exactly how static works. A static variable belongs to class itself, not individual objects. For example, static int student count equals 0. Every object shares this one variable. So if one object changes it, everybody sees the change. That's why you can access static things directly using the class name math.random. No object needed because it belongs to the class blueprint itself. Final, the ultimate restriction. The final keywords means no more changes allowed, but it behaves differently depending on where you use it. Final variable, final double pi equals 3.14. Now pi can never change. Java treats it like a constant. Final method, a child class cannot override it, meaning the behavior is locked forever. Final clause, no inheritance allowed. Even Java string class is final. Why? Because Java wants string to remain secure and immutable. Abstract, the incomplete blueprint. Now let's talk about abstract. An abstract class is like a blueprint for a car. You can design the blueprint, but you can't drive the blueprint itself. Example, abstract class vehicle, abstract void start. There no body for the start method. The child class must provide it. This force consistency across subclasses. Super powerful in enterprise application. Advanced modifiers. Now let's level up. These modifiers appear heavily in multithreading and enterprise Java, and honestly, this is where many beginners get scared. But don't worry, we'll simplify them. Volatility. Main memory access. Imagine office worker copying tasks into personal notepads. If one worker changes something or their notepad, the others won't know. That's exactly what happened with the CPU cache in the multithreading. Volatility forces all threads to read directly from the main memory, meaning everybody always sees the latest value. Example, volatile boolean running equals true. Now every thread sees update instantly. Synchronized, the bathroom key analogy. Imagine a single bathroom with a one key. Only one person can enter at a time. Everybody else must wait. That's synchronized. It prevents multi-threads from modifying the data simultaneously. Example, public synchronized void withdraw int amount. This prevents race condition and corrupted data. Super important in banking systems and enterprise application. Transient, hidden during saving. Sometimes Java saves objects into files or send them over networks. This process is called serialization. But what if the object contains password? You don't want password get saved. That's where transient comes in. Transient string password. Java skips this variable during serialization. Perfect for sensitive data. Interview type. Here, something interview love asking. Volatile does not make operation thread safe. It only guarantees visibility. That's huge difference. Alright, let's summarize everything quickly. Public access will be everywhere. Private only inside the class. Protected package plus subclasses. Default package only. And for non-access modifiers, static shared across objects. Final cannot change. Abstract incomplete blueprint. Synchronized one thread at a time. Volatile always read the latest value. Transient skip during serialization. Boom! You now understand Java modifiers better than most beginners. If this video finally made Java modifiers click in your brain, hit the like button right now. And if you know someone struggling with the Java OOPS concept, share this video with them. Also, drop a comment below. Which modifier confused you the most before this video? Was it volatile, synchronized, abstract, or static? I read every single comment and I love to hear from you. And if there are another Java topic, if you want to simplify next, tell me below. Thank you so much for watching. Keep coding, keep learning, keep building awesome things. And I will see you in the next video. Bye everyone.